Hello everybody, this is Legolas and we are going to work on a question from paper 1, mock set 3, autumn 2007. This is an Edexcel paper. It's question 15. There are only n red balls and n plus 1 blue balls in a bag. Excellent. Shamsa takes at random 2 balls from the bag. Show that the probability that both balls are the same color is n over 2n plus 1. Okie dokie. Okay, so let me start underlining some keywords in the question. N red balls, that's important. N plus 1 blue balls, that must be important. Okay, it's in the bag, excellent. Shamsa takes at random 2. Okay, 2 balls from the bag. Okay, so I'm assuming she takes a ball out and she doesn't put it back in, so it's without replacement. It says show, that's our command word, that the probability that both balls, okay, that's interesting, are the same color. All right, excellent. So what colors do we have? We have red and blue. So probability of red and red plus the probability of blue and blue. Okay, let's start with some expressions. Okay, so n red balls. So we got red. An expression for red balls will be n. I have no idea why I'm using the red pen. Blue, let's use capital B to represent the blue balls. That will be n plus 1. Okay, what do I need? So I want to know the probability of red. So let me do capital P. Probability of red equals, okay, probability of red will be n. Okay, probability of n. No, I know probability is going to be a fraction over the total. Okay, I don't have an expression for the total, so let's work out an expression for the total. Now, if I want to know the total, I've got to add up the number of red balls and the number of blue balls. Okay, so that's basically n plus 1. Okay, n plus n is 2n, so you've got to add the like terms plus 1. You can't add the 2n and the 1 because they're not like terms. This is 2 lots of n and this is just a number. So the probability of picking a red ball must be n over 2n plus 1, the total number of balls. Excellent. All right, let me work out the probability of picking out an a blue, sorry. So an expression to describe that. Okay, so the number of blue balls, it was n plus 1, so the numerator is going to be n plus 1. You have n plus 1 blue balls. Over the total, which is going to be the same, 2n plus 1. Okay, now I know it's a probability question. I know that I'm going to take a ball out and then I'm going to leave it out and then take another ball out and leave it out. So what I'm thinking, I'm just going to describe this using a tree diagram. So here I'm going to have a red, here I'm going to have blue, so I could pick a red, or if I go back to the beginning, I could pick a blue. So this tree diagram is just going to describe the things that could happen. So if I go back to here, so I could pick a red and I could pick another red, or I could pick a blue. Okay, if we start from here, I could pick a blue, then I could pick another blue, or I could pick another red. Okay, let's focus on the question. Both balls are the same color. Okay, capital P. So I want to know the probability of a red and a red. And I said and, remember, and in probability means multiply. And I want to know the probability of a blue and another blue. And what I'm going to do, once I've worked out what R and R are and blue and B, I'm going to add these two together because it's OR. So OR means add. Okay, let's go back to our tree diagram. Let's start labeling this tree diagram with some probabilities. So the probability of picking a red ball. Now what was it? N over 2n plus 1. Excellent. So let me just write that here. N over 2n plus 1. What was the probability picking a blue? N plus 1 over 2n plus 1. Okay, I could pick a blue. Let me do that one. N plus 1 over 2n plus 1. Okay, let's go back to the beginning. So I could pick a red. I'm going to take the red and I'm going to leave it out. And then I could pick another red. So the number of reds should have decreased by how much? You're right, 1. So an expression, so if I have n red balls and I take one out, it's going to be n minus 1 because I've taken one out. Over, now what's happened to the total? I've taken one out, so the total must have gone down by 1. Okay, so I've got 2n plus 1 and I must minus 1 from that. That will give me 2n. 1 minus 1 would just cancel out, so I'm just left with 2n. Now I'm not even going to bother with the red and blue because I don't need to work that probability out. I just need to know probability of red and red. So let me fill in the probability of B and B. So, okay, n plus 1 over 2n plus 1 was a probability of picking a blue. I need to pick another blue. So n plus 1 was a expression to describe the blue balls. I've taken 1 out. So plus 1 minus 1, they cancel out. So I'm just going to be left with n over, and then 2n plus 1, same as this one, decreases by 1 over 2n. Okay, let's go to this tree here, this branch here, branch R and R. Now, and means multiply, so that means I have to multiply these two fractions together. So it's going to be n over 2n plus 1 multiplied by n minus 1 over 2n. Okay, let me write an expression for blue and blue. That's going to be the same, n plus 1 over 2n plus 1. And when I mean the same, I mean we need to multiply these two fractions together, n over 2n. Now, we know that when you're multiplying and you have fractions, you multiply the numerators together and multiply the denominators together. So n times n minus 1. Now I'm just going to leave it as n minus 1 in brackets like so, over, and I'm just going to write like this, 2n, and I'm going to write the 2n plus 1 in brackets. And same with this one, so it's n over n plus 1 over 2n plus 1. Excellent, we're nearly there. Okay, so I've got my probability of red and red, this expression here. We've got my probability of blue and blue, this expression here. And now I need to add these two together. So let me add them in a different color. Let's choose blue. I like blue. So n over n minus 1 over, now, yes, if I notice here, look, the denominator here is 2n over 2n plus 1, and the denominator here is the same, 2n plus 1. So what that means is, when I'm adding these two fractions together, I can write them as a single fraction. So I can write the whole thing as over 2n plus 1. Excellent. Okay, now I said I needed to add them. So the numerator was n minus 1, there, you got that there, plus n plus 1. Okie dokie. So what I can do, I can expand this, and collect the like terms. So let me just expand it first. So I have n squared minus n plus n squared plus n, and the whole thing is going to be over 2n plus 1. Let me collect the like terms. So I've got my like terms, n squared and n squared. 1 lots of n squared plus 1 lots of n squared will give me 2 lots of n squared. Minus n plus n, they cancel out. Let me just do a little cross like that. And the new denominator is going to stay the same. And if you notice, okay, we have a common factor. 2n goes into 2n once, 2n goes into 2n once, and we're just left with an n. So we have now got an expression n over 2n plus 1, and that is the same as n over 2n plus 1. Now this is quite a challenging question. There's loads of different topics being tested here. The most important part of the question is definitely the first part. You got to practice writing R's, whatever color it is. In this case it was red and blue, as an expression, and then the probability as an expression. If you don't get this first part right, the rest of it's going to be completely wrong. Now the skills they were testing, so first of all writing expressions, and then your knowledge of tree diagrams, and then whether you knew how to do without replacement. You take a color out and you leave it out, so what happens with the probabilities. Then they were testing whether you knew the and rule, whether you knew to multiply these two fractions together. Same with the blue. And then they were testing algebraic fractions, so multiplying algebraic fractions, and then adding algebraic fractions, and then cancelling down. So quite a lot of different skills were being tested in this question. I hope you liked the video. I hope you learned something. If you did, please subscribe to the video and click like. You'll be doing me a big favor. This is Legolas signing out. Till next time, see you later.